This app can read any PDF that you send it, store it in a vector database, and answer any question that you like as many times as you need, running locally using AI. For example, um, let's just, as you can see, one file uploaded successfully. Now, bear in mind with me, this AI model particularly is very slow as I am running it locally. And due to the high consumption of AI, the particular high consumption of things like RAM and computation power, my limited resources of the LLM running locally means my response time is going to be fairly slow. Although later down the line, I am planning to add additional cloud infrastructure to this to improve the response time. Of course, we are trying to integrate this with a user base. We would want to put our file in, put our query in, bam, get a response instantly. And unfortunately, as you can see, that's not exactly what we're getting here. So bear with me here. There it is. Um, as you can see, if I haven't mentioned, the file is based around, I believe, health and social. So as you can see, it had given details from the PDF. For example, it mentions the World Health Organization. Second of all, the exact quote linked here, the same one that's in the PDF. Additionally, it does have some extra sections as well, having a positive mental outlook, which I don't believe was in the PDF file. Now, before we get any other stuff regarding the architecture breakdown, there are a couple points I'd like to mention first. And most importantly, I'm just get started working with this project. First of all, you need Next.js. Next.js and a fairly good amount of Tailwind CSS, as this is what a majority of our front end is written in. In fact, all of it is written in Next.js and Tailwind CSS. Although you could substitute React and install Tailwind CSS manually, as they do have they have very similar functions, like their component structure. Second of all is we need our secondary API. You might be asking, what is our secondary API? Well, that's really simple. Our secondary API is going to be the API that handles all functions outside the primary one of this application. For example, right now it's in MVP, a minimally viable product. As you can see, a simple chat interface, a button to upload documents, and a simple chatbot, a question, a response. However, later down the line, if you need to do something, for example, if you need to have a payment service, or you need to add authentication, or you need to check what's actually being typed within this, or you need to log errors, you need an API that can handle all of that. For me, I personally chose JavaScript because, and particularly the framework is Express, as I have been using Express for the longest time for now. And I have a tech stack built around it, including Stripe for payments, JSON web tokens, etc. The second thing you need is your primary API. Now, our primary API is only one task and one task only. Deal with one service. That service is the AI, particularly the query and the PDFs. For that, I'm going to be using Fast API as it's also written in Python and fits very nicely within our AI backend. And fourth and finally, it's not exactly necessary as we do go into breaking individual components, but having some overall architecture idea of how a RAG system works will really help understand what we're about to get into. Um, like I said, it's not necessary, but it'd be great if to any of you who do have that knowledge, it'll be extremely helpful while we're going through. The complicated parts aside, let's dive straight into the architecture. Now, the first thing I'm gonna be explaining is the client. Well, the client isn't too difficult. Anyone can understand that if you've developed anything regarding software, any software products, you know what a client is. A client is just simply the user. In this instance, when it was running locally, I was the client, as I was the one who was sending the data in and asking the questions. Now, the client is going to be sending two important things to our system. First of all is the PDF, and the second thing is the query via the Next.js front end. Now, where do these two individual components go? Well, fairly simple. First, the PDF. As you can see, this is after the Express API and our Fast API, every other individual square you see here is part of the AI backend. Typically, if you're talking about the PDF in particular, it's going to be everything to the right of Fast API here. That includes loading, embedding, and vector store. So now, when the PDF actually enters the Fast API and gets sent, what is the first thing that happens? Well, the first thing is very simple: loading. Well, loading, essentially what it is it's just going to pick up all the data and turn it into a string. So what it's going to do is it's going to take, let's just say, let me pull up a PDF here. Let's just say this is our PDF right here. Essentially, all the loader's job is to do is to take this and turn it into a string, or I think a one-dimensional list. This list contains all the information from the PDF. Now, the second thing is going to happen is it's going to be broken down into chunks by a chunker, which, funny enough, I failed to mention. I failed to include as part of this AI backend system. But what a chunker is doing is very simple. It's going to take the chunk size and a chunk overlap. And what it's going to do is it's going to be creating sections based on the chunk size. For example, this is one. This is our second chunk. Let's say this is our first chunk, this is our second chunk, and this is our third chunk. Although I have seen recently a lot of AI and AI devs show them as three individual components. As you can see, I've shown right here. But that's not actually the case, because if that were to be true, then there wouldn't be any need to have the second section, which is also known as chunk overlap. Chunk overlap just means the maximum amount of characters these chunks are allowed to overlap over each other. So instead of looking like this, they'd typically look like this. You're going to have your first chunk here. And then the second one's going to be put right here, overlapping with the first one. And that's going to be our third one right here. They more so act as one individual unit, but also have their individuality in them. It's pretty difficult to explain, but think of it like this. Say I give you a book and I ask you to memorize every single part of that book, and then I ask you questions later. Well, you wouldn't read the entire book in one sitting. You'd read it based on certain amounts of pages. So maybe you'd read, say it's a book of 100. Maybe you'd learn 33 the first day, 33 the second day, and 34 the third day. This essentially reduces the amount of work you have to do, first of all. And second of all, it helps you retain more knowledge each individual day. And each set of these pages are separate pages, but they're still part of the same book. Essentially, how chunking works. These chunks, and it's going to turn these strings within the individual chunks into numbers. Different things. Let's just call this 2. Let's just call this 3. Now, the final thing, which I had accidentally mentioned earlier, is the vector store. Well, what is the vector store? The vector store is really simple. Essentially, these are our numbers, and let's just, there isn't much space here, but let's just call this our vector database. It's our VDB. All it's literally doing is it's taking these that have been turned into numbers, these chunks that have been embedded, and it's just storing them within this for later use. And that essentially is what vector store is. And finally, the query is going to be first hit our fast API. It's then going to be rerouted to our embedder here so that the query, let's just call it QU in this instance, is also turned into a list of numbers. Let's just call this 5 here. Or actually, let's call it 0. And finally, it's get forwarded to the generator. Now, what this generator is going to do is it's going to be taking this embedded query, and then it's going to fetch the most relevant context based on cosine similarity. So essentially, to break this down, is it's going to take your query, it's going to send it to your vector database, our vector DB here, and it's going to be finding the chunk that is most relevant to the context here. So let's just pick number 2 as our most relevant chunk according to this query. So it's going to be returning our second chunk into our generator. And then finally, the second chunk, the one that our most relevant chunk, also known as our second chunk, is going to be with our query, our query right here is going to be sent to an LLM, ChatGPT or Olama. I ran mine through Olama, but as you can see, it's fairly slow when you run it through Olama. So I think maybe when we're going to be rebuilding this, I might consider using the ChatGPT OpenAI's key. Although there is one issue that there are paywalls considering it, so it might not be the best option. And if you have high enough specs, I think it's a Olama is a better choice. And finally, it's just going to be sent back, and then it's going to be sent, and the answer is going to be shown on the front end to the user. That we're done with that, let's dive straight into the coding. For an editor, you can either use Visual Studio Code or Cursor. Either one's perfectly fine. But I'm going to be using Cursor because I just have a little more experience using Cursor. I think this is to prompt a local agent, if I'm correct. Yeah, just close this window. We're not going to be using this. Let's just create a new terminal. You could also do it here by just clicking on terminal and new terminal, but there is a shortcut, so that's what I'm going to be using. Great. Now we're going to be creating our first folder, which is going to be our Next.js frontend. I'm just going to call it rag underscore chat underscore frontend. I think it, just 1 second. I see the mistake here. I was supposed to hit mkdir, which means it creates a new folder. Never do this. So it's mkdir rag underscore chat underscore frontend. To me, this is pretty self-explanatory, but you can name it whatever you want. As long as you understand what each individual folder does, it doesn't really matter. Now we're just going to be moving into that folder. So cd, which just means change directory, underscore chat underscore frontend. And there is a command to, I already copied it, so I'm just going to be using that. What is your project named? I'm just going to keep this as my app. I'm just going to be using default settings here. Now, in the meantime of this, we'll just create our our other folders. It seems to be slow here. Odd. Hmm. Have accidentally opened two. I'll just close one here. Now, while that's downloading, let's just open a new terminal. Let's say mkdir again, which just means make directory or make a folder. And let's call this one rag underscore express underscore API. Uh, and then we're going to go cd rag underscore express, just a file name. I think it would make more sense if we just open the folder here, because we'll actually see what's happening. Open folder. There it is. Let's just type in the name of our folder here. Rag underscore express underscore API. I'm not going to be using this. Now we're just going to open our terminal. So again, we're just going to use Control Shift single comma. And now that we've moved into our handler, and what else? I'm not very sure. And then I also need Mongoose just to start us off. Now I believe it should have finished installing by now. Ah, there it is. Perfect. I was a bit confused why that wasn't working for a second. Now, if you see, you're going to see your layout.tsx and your page.tsx. This is mostly the one you're going to need to worry about. This is where most of your coding is going to happen, at least your home page. Now, to run our front end, we're just going to go terminal here. We're going to go cd my underscore app, and it's npm run dev. Npm run dev is pretty simple. It's just node package manager run, and then just a dev script, essentially running a development environment here. There you go. One issue already. We're gonna need to look into that in a minute. But for example, if I replace this localhost here by 127.0.0.1, it's essentially just gonna come up as the same page. Come back here. It should come back as the same page because localhost just means, yep, as you can see, the exact same. Now, if you want to get rid of all this code, which I'm going to be doing, you just got to get rid of all of this multiple sections instead of having one section and all your code written in here. So I can just create a div here and just render home. That should have gotten rid of all the code over there. Let me see. Copilot, Microsoft Edge. There you go. It does just run home as a background here. You don't even need the next underscore image. For the layout.tsx, we're just going to get rid of most of this. For example, we don't need this at all. We don't need this font here because we're not using any app. I think that's just clear. And for the description is creating a drag chat application. Yeah, that seems about fine. It should be running. I believe the background should be white now because we did get rid of almost every. Yeah, there you go. But yeah, this just renders the entire background as white. Now, time for main, our secondary API. Actually, we're going to create a main folder here, and in this main folder here, we're just going to create a new file called main.js. Although I have seen some people just go server.js or even index.js. I'll just use index.js because it's most used. You're going to import. First of all, we're going to need to connect this to a database. So you're just going to need to import uh, mongoose from just to you can just initialize a port that this is going to be listening on. Um, Bear in mind another port that we've mentioned here is here. When it says 3000 here, that's just a port it's listening onto. So we're just going to be initialized port equals to 5000. And then we gotta define the main section of our application. So that's why I have my Google Chrome tab open over here. So you just need to go to MongoDB Atlas and you need to just sign up with Google. I don't really. I never really bothered creating an account, so I just signed in with Google and it works perfectly fine. You just need to create a new project. It already created one for us over here. So I'm just going to be using, I'm just going to be connecting to this one. I'm going to be using drivers because, of course, I have Mongoose. Um, Cluster, but DB password, which takes in an arrow function. And it should be the things up a bit. I have finished off most of the code here, but the explanation is really simple. So these are just the two packages that we're using. We're going to be using Express and Mongoose, and then we're going to initialize our app here. So const app equals to the Express function, and then we're going to set the port that our app is going to be listening on. Next, we send the connection string. Now, the connection string you saw, it's a bit longer than the one you saw earlier. This is because for some reason it doesn't work with an SRV connection string. So let me show you right here. By the way, this is a quick tip to anybody who's having a hard time. This is for people who've tried everything and nothing exactly seems to be working. Just click on drivers here, and you see what it says SRV connection string. You just turn that off. It's practically the exact same thing, but I just found that it's always a good idea to just try this, just in case it isn't working for you. Anyways, if I remember correctly, where's my cursor? There it is. Now there it is. Anyways, then we're gonna set this is the main body of our app, so it's just gonna be Mongoose, the thing we imported up here, dot connect, which is going to be used to connect to our database here. Mongoose con or connection string was initialized up here, like I mentioned earlier. Then this is going to saying app.listen, which means it's going to be essentially listening at it. The argument it takes here is a port number, which we've given up here as 5000. Then it sets an arrow function here, and then console.log, which essentially just prints it. The app listening on port, this just prints out the variable over here. So this says app listening on port 5000. And then catch is error logging. Usually you want error logging, especially when you're writing functions, because if you don't have things like .catch or try catch blocks, when you run your code and there's an error and you don't have this, it just doesn't print out the error in the error logs. It just doesn't show up. Anyways, to start this, you just go node index.js. Now that we're done with our Express API, let's dive straight into the front end. Now, it doesn't really matter much if you had a hard time with the Express API and couldn't get to run, because we are using it later down in the series. But if you want to finish the entire series as a whole, we will be using the Express API. So if you're having a hard time with that and you just want to complete the MVP tutorial, that's perfectly fine. It's just if you want to finish the series end to end, I highly recommend you go back and watch the Express API and try and get that done. Now, with that out of the way, let's dive straight into the code. Now, the first thing you see here is this use client. Now, in Next.js, there are two types of components. There is a server-side component and there's a client-side component. Now, our server-side components are typically used to communicate with our backend. In our case, in my particular case, is going to be our Express API and our Fast API. But our client-side components is going to be anything related to the user communicating with our user interface here. And it's going to be used for the React hooks and things like on-click functions. Basically, anytime you need any sort of functionality with our website, we're going to need to convert it to a client-side component. Now, all components in Next.js are automatically defaulted to server-side components, but can be turned into client-side components with this use client string here. The first library we're going to be using is our Axios library here. Now, Axios is an HTTP library I use. It's a lot, I find it a lot easier to send HTTP requests via Axios compared to just writing it in just raw Next.js. And I'm also going to be using Lucid React here. Now, Lucid React is a UI library that's going to help us import things, import pre-built components to make our workload a bunch faster. Now, they have rendered the bot component somewhere down here. I'm not exactly sure where. Anyways, moving on. Right after that, it initializes our component by saying export default function home. And then right after that, it begins our first use state by using const messages, set messages. Set messages used to set the value of the use state. And then it sets the use state. And then it has the value of messages in here. Without looking at this code, you immediately know it has something to do with this. And then they begin to fill the values here. And it says the role as assistant and the text as just a basic prompt here. Of course, it'll be rendered later down in the line. Now, we're going to have three use states here. Our first use state is going to be used. Our first use state here is going to be used to catch the value of input. Now, in our UI, if we did not have this webhook, we wouldn't be able to catch the value of input. Now, for our second use state, is to simply detect whether it's loading or not, and to trigger a certain function when it does. And then finally, we have uploading and set uploading, which similarly to the loading and set loading, just detects when you're uploading something. Then it initializes a value called const bottom ref, const meaning constant. And then it has the HTML div element and sets to the value type of null. And then it starts a use effect here with an arrow function. And then it starts the bottom ref, the value initialized over here, and then it initializes the current value in it, and then initializes a scroll into view function. Now this just sets our scrolling to be a bit smoother, and then it sets the list to be of messages. And then right after that, it begins a function called handle upload, where it creates a value called e, and then it sets it to the react.change event of the HTML input element. Now, this particular one is going to be used to append the value of our files in our HTTP request. As you can see later down here, it says const files equals to e.target.files. And then it says if not files, just simply return, which means if there are no files uploaded, just stop the program entirely. And then it sets form data equals to a new form data function. And then it sets a for loop here that says for const file of array from files, which means for file in the array from the files up here from the HTML input element. And then it sets a try catch block here. And the try is going to be set uploading equals true, which is a function up here. And then it sends a post request to our fast API, which we are going to build later on, at localhost, which is 127.0.0.1, to our slash upload path. And then it adds the assistant manager, and it passes in a string with the value of the file's dot length. And then it catches any errors and simply just prints it out here. And then add assistant managers upload failed. I'm assuming this add assistant message is just going to console.log the string you passed to it. And then finally, it's going to set the uploading to false. Then it starts an async function called send message. And it starts with an if block that says if not input.trim or loading, simply just return. So the .trim function just gets rid of any white space between a string you pass into it. So I don't have any place to show it to you, but I'll just show you via these comments here. So if you say const message equals to, and then just set it as a string, and we just go hello. To get rid of any of this white space between the hellos here, the hello, we use the .trim function. So if we do console.log message.trim, our output here is just going to be as a string, of course. This is because the .trim function essentially just gets rid of any white space between a set of strings. Now, you might be wondering what's the use of that particularly. It's going to be very helpful later on, especially when we're sending it via our form data, because in our form data, we wouldn't want to be wasting any space. Anyways, the next thing it does is sets a value of question to the input, which is likely going to be our query, mind me. And then it's going to add our user message to, and it's going to append the value of the question, and it's going to set input here, the use state I mentioned earlier, to an empty string, and it's going to set the set loading to true. Essentially, it's saying initialize the string, and it's going to start loading soon. And then it's going to set, and then it's going to it's going to set the value of a response here to the response of this axios.post request to our fast API here in our slash query path. And then our query is simply just going to be the value of our question. And then it's just going to add the assistant manager. Sorry, the add assistant message. I have been messing that up quite a bit. And then it's just going to parse in the response.data.answer. And then it's just going to print out no answer returned. And then finally, the catch statement is simply just going to catch the error, print it out. It's going to use the add assistant message. And then it's simply to print out something went wrong. And then finally, it's going to set the loading to false. And then we have another function, which is add user message, that takes in the value, takes in a parameter of text as a string, and then it sets the messages to the previous message. And the role is going to be of user, and then it's simply just going to put the value of the text here, as it's just going to be one of our parameters. So if we were to call on this function, add user messages, and then we pass in the value of, and we're just going to pass in the value of test. The value that's going to be put here would also be test, at least a string of test, right here. And then the next function it creates is the add assistant message, which is also going to be taking text as a parameter. And it's going to set the messages to the previous, and then it's going to add the role to assistant, whereas the difference was here the role was as user, and also the value of text. And then finally, it's going to be the HTML here. This H1 is it says rag underscore AI, and it's situated right at the top. So that's going to be right here. The second one is going to be our input with our handle upload function. Now our handle upload function is going to handle all of our files. So it is likely to be this right here, because for uploading our files here, we're going to be using an input here and a small framework with it. And then finally, the upload function we've added up here via the Lucid React library. And then it says click to select documents. This is likely also part of the input. The AI RAG chat assistant, of course, is going to be here, is rendered right here. And then it just maps, and then essentially it's just mapping our messages based on the message and the index of the message. And essentially what it's doing is it's checking, is the user and the message's role equal to user, then return a div with the key as its index, and the class name here, some basic Tailwind CSS. And then if not user, and then it just renders some HTML in here, and then it renders the bot inside here. And then it just renders our bot here. And then it has a div, and then it further renders some more Tailwind CSS. And it also checks is user, which is a Boolean mentioned earlier. And then it's rendering in a paragraph the message.text. And then it's further rendering is user. It's just checking is the value of is user true, or is the person a user, and then it just renders the user and then at the size of 18. Just getting to the important part here. Finally, there is our input. Our input is gonna have a placeholder that's gonna be asked about your documents. This input over here. And then the value of it's gonna take is just gonna be input. On change, it's gonna set the input to the target.value, which means it's just gonna set the value of the input and just log it within this use state hook. And then on key down, it's just gonna send the message. And finally, with the button, it's gonna activate our send message function here, and then our use state for our load. Now, it's the moment we've all been waiting for, the RAG pipeline and the fast API backend. Now, we have two packages here. We're going to be using OS, which is operating system, which is the usual library people use in Python to interact with files. And then from PyPDF2, it imports a object called PDF reader. Then it begins our function called load underscore file that takes one argument of the file path as a string and returns a string. You don't need this arrow and then this string here, but it does make our code a lot more readable. Then it extracts our extension by using os.path.splitText file path at the index of 1, and then use the lower function, which turns any uppercase string into lowercase. Quite self-explanatory there. And as you can see here, it extracts the file extension. And then it sets up our try block. And then it checks if the extension is equal to PDF. Then it sets the reader to the PDF reader at the file path, which is going to be passed up here. And then it initializes a variable called text underscore paths as an empty list. And then it creates a for loop that stores the value of the reader at the file path. It stores the value of each page of the reader in a value called page. And then assigns our first variable, page underscore text, to the page value of the reader at our pages. And then it uses the extract text function to essentially just get all the text from the PDF. And then if the page text is created successfully, it's going to append the page text to the text paths. So this essentially is going to be our PDF turning into our string, and then that string being stored in a list. And then it's going to return with a new line character using the join function, the text paths, and then strip it once more. And then if the extension is txt, it opens a file with the read command. The R just means you're able to read certain portions of it. And then it sets the encoding to UTF-8. The errors, just ignore all the errors, any error you might have on the way, as F. And then return f.read.stripped. So this essentially just extracts all the text from our text file. And then it returns a string here. And then this is error logging, but it also returns a string. That's why you have this part of the section here, because later down the line, if anybody else is going to look through our code, they need to look at it at a glance and know, I know what this code does. So if anybody looks at this, they'll be like, this takes in a string known as file path, and then it just returns a string. Now, we're going to get to our second part, which is our chunker, which is really simple. It's having a function called chunk underscore text that takes our text from our previous function as a string, and then the chunk size as an integer of 500. And if the text is a string, it'll just return an empty list. Or if it's not, it's going to use the text.strip function once more, just in case we missed it the first time, and then just returns an empty list. Now, we've gotten through two very crucial parts. Let me just get rid of this. We've taken our PDF. Let me just make it full screen here. We've taken our PDF here. We've turned it into a string contained within a list. And then now we finally got it to split into individual chunks. Let me just create a chunk here. You might be wondering, how do we know the size of each individual chunk? Well, It's a one of the arguments here is a chunk size with the integer of 500. So each individual blocks is going to be set at our chunk size, which is going to be 500. Let me just set this here. Now, our next step is going to be embedding. Right here. Right here, I believe. Yeah, embeddings. And then it's going to import a package called sentence transformers, and more particularly it imports this function sentence transformers, which allows us to import any LLM model so that we can embed all of the PDF. The entire section of the PDF it will be embedded by an LLM model, and then it initializes our model as a sentence transformer function, and then passes in a string, which is the name of our LLM model. And then it creates a function here called embed that takes text, as I mentioned earlier, in our chunks. In our chunker also returns a string. It takes the text as a string, and then it's just going to return the model encoding the text, and then it's just going to embed it here. And then the embed batch also takes in the text, but it's going to take it as a list containing a string. So that's going to be, I'm not very, I think, I believe this function is going to be for our query here. And this function is going to be used to embed our PDF here. Because our query is going to come in simply as a string, and then our chunker over here returns a list containing the string. So the embedder is going to use this embed batch function to embed the PDF, and this to embed the query so that we can use it for retrieval. Now, it finally the next step is the vector store. Let me see. And now that we've gotten each individual one, and let's just create this into a random binary, although we're not going to actually feed our data into binary. 0, 1. It just makes it a lot more visual for the conversion. Let's just say 1, 1, 0. And then let's just turn this. In all essence, embedding doesn't usually return strings like this, but just for the sake of getting the overall idea, I think I'm just going to return it like this. Now, we've gotten each individual section. We've gotten our PDF. Then we loaded it. Then we chunked it into chunk sizes of 500. And finally, using our LLM, we've embedded them. Now, our final step here, and this one's going to be crucial, is to store this entire section. If you were there for the architecture breakdown at the start of the video, then it's going to be put into a vector DB. This entire section at the start, I mentioned taking the entire section of our chunks and then forcing it into a vector DB. Now, the code that is responsible for it is the vector store class here. It's going to create an index here, and then it's going to just create the text as an empty string. It takes the dim, which as an integer, which just means the dimensions. The dimension size is essentially how wide and how tall is it allowed to be. And then it's just creating an add function here, which takes self, the embeddings, and the text. And then if the length of the embeddings is 0, it'll simply just stop the program, because why run any further into storing it if there's nothing to store? And then it sets the embeddings to a numpy array of the embeddings and then turns the type into float 32, which means it just has a bunch of integers on the end. And if the length of the embeddings and the shape is equal to 1, the length of the shape of the embeddings is equal to 1, it sets the embeddings to numpy dot expand. It expands it to the size of the embeddings with an axis of 0, and then it adds the embeddings to the index and then extends it to the text. And then it creates a search function here. This search function is going to be used in the process of retrieval. And then it just checks if the index total is equal to 0, just return an empty list. And then it says to query embeddings to a numpy array, I'm assuming with the query embeddings appended to it, appended to this numpy array, back to the as type of float 32. And then if the length of the query embeddings is equal to 1, it's going to expand the divs of an axis of 0. And then finally, and then it just searches the query embedding and then puts in k here and then returns the self text for I in the array of 0. And if I is the less than the length of the self dot text, or just the text here. So essentially what this does is, this vector DB, it also creates another module here. And it's essentially what our search function here is going to do. This search function is what our retriever is going to be using, which we're going to be looking at in a minute. Retriever. This retriever is going to connect back to our search function here, which is then going to communicate with the vector DB. And the vector DB is going to, the search function is going to look through the vector DB based on the query and check what's the most value, the chunks with the closest value based on our query. And then all it's going to do is, once it's done, it's just going to return it back to the retriever. Now, the retriever is going to import the RAG embeddings. As you can see, the folder is called RAG, and it's just importing the embed function. And then it creates a function called retrieve, and it takes vector store as an argument here, or a vector store here, likely, and the query as a string, which we're going to see later on. And if the query is not in the instance of the string, to just return an empty list. So this is essentially checking if, I think it's, yeah, it checks if the query exists. Because there's no point conducting a retrieval of the most relevant chunk if there's no query to search based upon. And then this just checks if there's anything stored in the vector DB. Because it's useless to have a query that gets embedded if there's nothing to search in the vector store to begin with. And then the query embedding is just going to be the embed function on our query. So this converts our query into n for a vector search. And then it finally sets our try block here, and the results equals to the vector store here, the vector store class we saw earlier, and it accesses from this class, it's accessing the search function, and then it sets the value of k as 3. And if there are no results, of course, just return an empty list. And it sets a value of clean here to an empty list. And then it runs a for loop that says for r in results, if there's an instance with the value of r and a string, then append the value of r to the clean here. Elif, which is just else if instance r is a dictionary and text in r, just append the r, a list, and just append the value of text. Else, it should just append r as a string and then just return clean here. Except exception, just return r, which just means in any other exception, just return an empty list. Now, finally, it's going to be our generator here. It's going to import requests so that we can ping HTTP requests. And then it defines a function here called generate answer, which takes our query as a string and our context as a list of a string. And then it finally prompts our Olama assistant that's running locally here. You are a helpful AI assistant. The context is the character, the first 10 characters, and you just join them using and appending the context here, and simply just puts the context here and the query. And that's essentially the overall on how the generator works. Now, what are generators doing? After our retrievers retrieve the value here, let's just call this our generator. Narrate. What is just going on here? Generator. Excuse me for my poor writing skills. It's just gonna send this the query and the most relevant chunk, and then that's just gonna send it to our Olama here, our Olama agent running. Olama, which is just gonna return the response. That returns it back here. That talks to our API, which we're going over in just a minute. And that communicates with our Next.js frontend. And that just and now the next thing we're going to be doing is our API, the final part, the final piece of the puzzle. It imports a bunch of models here. Sorry, not models, a bunch of packages here. But I'm not going to go too in depth with them. And it also imports everything else I've covered so far. It initializes our app as fast API, and then it as CORS middleware. Now, by default, APIs don't allow communication with any other applications unless you add CORS middleware. CORS literally translates to cross-origin resource sharing. So an API usually would not let you communicate with any other application unless their URL is written within the CORS policy. Then it creates a class as query and then use our base model and just sets the value of query to string. The upload directory, and it just sets the upload directory to uploads here, this folder right here. And the allowed types is going to be a PDF, just plain text, and then just other documents. The vector store is our vector store class I mentioned earlier with the dimensions, which were an empty value earlier to 384. App.get a root directory, and then it just sets the it's just a health check here to see if it's just running, if there are any issues before we initialize our project. It's usually done just for that, just for the sake of quite literally just a health check. Then it creates our upload. Again, I'm not going to go too in depth with this because if you've kept up with everything until now, all of this is going to be fairly simple. As you can see, the embeddings here, the vector store, and it's adding the embeddings in the chunks. And then it's just going to return the status as true, the uploaded files. And then it's just going to have it's going to have the exception here just to just going to console.log the error. And then it creates our query here. That's going to it's just going to strip our query here and then just raise an error if it's an empty query. Sorry. And then it's setting a try, and it's just getting the context, and it's just retrieving based on the query, and it's generating an answer, and then returning the status, the answer, and the context, and it's raising an HTTP error just in case there are any errors within our application. Now, to start this, we're going to be running, we're going to go cd main, because that's where our main.py is. And then it's just going to go, if I'm correct, uvcorn, which spins up a virtual environment, and then it just gives main, and then just dash reload. Well, so that pretty much covers our front end. Just quick, I'm just going to quickly run it and show it to you just to prove that it works. Now, I finally got this thing running. As you can see here, everything's running. I have proof for you to show both of them are running. As you can see, this is running, our API here, and our page.tsx is also running. In fact, we can look at it happening live. As you can see, I had a couple of tests here. /upload, hitting each of our endpoints, our /upload and our /query endpoints. Now, without further ado, I'm going to be using the exact same file as earlier because I don't really think it makes a difference overall. But I've just memorized what's in that PDF, so that's probably what I'm going to be using here. Let's see. There it is. And then I'm going to send in my query. If it's anything like the one we saw at the start, it'll take a really long time to answer. Now, the app we've built so far is just going to be just the bare bones. Like I said at the start, it's an MVP. It's literally the lowest of the low. Just the pure functionality of an AI chat assistant. Though, in the next part of our series, we're going to add a basic sign-in feature, and we're going to add all authentication and JSON web tokens. On top of that, we're also going to improve the speed of our model here, because as you can see, this one is not the fastest. So let's see here. Should answer right about now, but should take a while. Yep, there it is. It's the same response as earlier because our input hasn't changed and our query hasn't changed. So stay tuned for future parts of this series where I'm going to be including more and more sections as part of our as part of the series. We're going to start adding more and more and more features. Eventually, we're going to get to a point where it's going to be publicly deployed so anyone can access it, and on top of that, it's going to have subscriptions and authentication. It's going to be great.